This question is to calculate the correlation coefficient between two dependent variables within a repeated random experiment. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Thank you so much. A random experiment has three possible and mutually exclusive outcomes, labeled A1, A2, and A3. Each outcome occurs with equal probability of 1/3. The experiment is repeated independently 2 times. Let x be the number of times outcome A1 occurs, and y be the number of times outcome A2 occurs. What is the correlation coefficient between x and y? There are 4 options. First step is to understand the distribution. Each trial produces exactly one of the 3 outcomes. Since the trials are repeated independently 2 times, x, the number of times outcome A1 occurs, follows a binomial distribution with 2 trials and success probability 1/3. Similarly, y and z, which count the number of times A2 and A3 occur respectively, also follow the same type of binomial distribution. Note that even though x, y, and z are each binomial, they are not independent because only one outcome happens in each trial. This dependency matters. Next step is to use the relationship between x, y, and z. In each of the 2 trials, only one outcome occurs. So across both trials, the total number of outcomes must be exactly 2. That means x plus y plus z equals 2. This lets us express y in terms of x and z. Y equals 2 minus x minus z. This identity is crucial for finding how x and y relate. Next step is to calculate the covariance between x and y. We want to compute the covariance of x and y. Using the earlier identity for y, we substitute covariance of x and y equals the covariance of x with 2 minus x minus z. Now we apply the linearity of covariance. The covariance of x and a constant like 2 is 0. The covariance of x with itself is just the variance of x. So we get covariance of x and y equals 0 minus the variance of x minus the covariance of x and z. Here's the key insight. By symmetry, the covariance of x with y is the same as the covariance of x with z. So we can replace the covariance of x and z with the covariance of x and y again. Now we solve. Covariance of x and y equals negative variance of x minus covariance of x and y. Rearranging, we get twice the covariance of x and y equals negative variance of x. So covariance of x and y equals negative 1/2 times the variance of x. Next step is to compute the correlation coefficient. The correlation coefficient is defined as the covariance divided by the product of the standard deviations. Since x and y have the same variance, the denominator becomes just the variance of x. So the correlation coefficient equals negative 1/2 times the variance of x divided by the variance of x, which simplifies to negative 1/2. The correct answer is A, which is negative 1/2. Whenever variables add up to a fixed constant, like x plus y plus z equals 2, they're automatically negatively correlated, because increasing one must cause the others to decrease. This is a powerful shortcut to spot in problems like this. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much.